Yeah, there's a disease that's killing off, it, like, uh, it's not a parasite. My mind's saying it's something that like it's white. It looks like white powder on their nose to some degree when they have it, and it's. I should probably. Is it a? Okay, my mind's dying on how to spell stuff, but then again, I am dyslexic along with everything else. Yeah, pathogenic pollution and avert human transportation of diseases. See, because it's actually caused by humans is the other thing. Of course, this is also a side subject kind of thing, but hey, I'm good at being distracted. ADHD. Um, but let me see. Yeah, white nose syndrome. There it is. But yeah. Will we actually talk about the white nose syndrome? Yeah, it's most devastating epizootic wildlife disease of mammals. The infected animals act erratically during winter hibernation, sometimes emerging from caves where the fungus easily spreads during the day and then not returning. Yeah, it's a fungus. The white nose began the strike more than a decade ago, Ford says, originating in Europe and Asia, eating away at the membranes of their wings. The disease left piles of dead bats marked with telltale white dots in the caves where they hibernate. The sickness seems to wake them from their winter slumber early, depleting critical fat reserves and causing dehydration. When they leave the caves too soon, they die from exposure or starvation. But yeah. Oh yeah. We accidentally carry in the fungus. It's on our clothes and all this other stuff. White nose syndrome kills over 90% of the northern long-eared little-nosed tricolored bat populations in fewer than 10 years. Yeah, it says there's no known cure for it. Uh, but yeah, we had to be very safe when I remember going there. It has since spread. First documented in New York in 2006, the white nose syndrome has spread across 35 states and 7 Canadian provinces. Has been confirmed in 12 North American bat species. We found that 9 out of the 10 bats of the most vulnerable species are now gone. Let's see. Yep, the fungus can persist on human clothing. Though it says, but as of 2016, it's not. Okay, that's new information I did not know. It's caused by fungus. Let me pull that up. But it's still safe, better safe than sorry on that one. Cause, preferably, the laboratory experiment says that physical contact is required for one bat to affect another. This implies that the fungus is not airborne, or at least not transmitted from bat to bat through air. Well, the thing is, one of the things, if I remember, about bats is they are very cuddly and cleaning and all this other stuff. It's likely the fungus was brought to North America by human activities. Because no bats initially immigrated between Europe and North America, and the fungus was first discovered in New York, where there was major transatlantic air and shipping terminals. Research has shown that the fungus can persist on human clothing and thus could be carried between locations by people, but as of 2016, it has not been demonstrated that this played any role in the spread of the disease. Say, like species of the genus Geomasis. It was previously unknown whether this fungus was a primary cause or opportunistic pathogen. The strong evidence shows that the fungus was the ethological agent. The fungus believed to originate from Europe. The current locations include Austria, Belgium, Czech Republic, Denmark, Estonia, France, Germany, Hungary, Netherlands, Poland, Romania, Slovakia, Switzerland, Turkey, Ukraine, and the United Kingdom. So, yeah, it isn't native. That's kind of sad. Anyways, back to other things. Well, since I'm already on the bandwagon of problems, real quick, so I can cut this up easier, I'll go ahead and put this together with it. Why air pollution bamboozles pollinating bees. Contaminated air is not only bad for us, but it can also disrupt bees' highly attuned senses for finding flowers. In the summers of 2018 and 2019, ecologist James Rowles and his colleagues would go out to the field near Reading in southern England to stare at the insects buzzing around the black mustard plants. Each time a bee, a hoverfly, moth, butterfly, or other insect tried to get pollen or nectar in the small yellow flowers, they'd make a note. It was part of an unusual experiment. Some patches of mustard plants were surrounded by pipes that released ozone and nitrogen oxides, polluting gases produced around power plants and conventional cars. The other plots had pipes releasing normal air. The results startled scientists. Plants smothered by pollutants were visited by up to 70% fewer insects overall, and their flowers received 90% fewer visits compared to those with unpolluted plots. The concentrations of pollutants were well below what the US regulators consider safe. We didn't expect it to be quite as dramatic as it was, says co-author Robbie Gerling, an entomologist at the University of Southern Queensland in Australia and visiting professor at the University of Reading. A growing body of research suggests that the pollution can disrupt the insect's attraction to plants. At the same time, when many insect populations have already suffering deep declines due to agricultural chemicals, habitat loss, and climate change. Around 70% of wild flowering plants and around 35% of food crops rely on animals to move pollen around so that plants can fertilize one another and form seeds. Even the black mustard plants used in the experiment, which can self-fertilize, exhibited a drop of 14 to 31% in successful pollination as measured by the number of seed pods, seed per pods, and seed pod weights from plants soon engulfed by dirty air. I'm going to say this just as a general joking thing with mustard seed pods and stuff. One of the things that was fun to do, I think in spring, or is it more like closer to fall, with the seed pods for mustard seeds, is they're kind of explosive. So if you run your hand across them, they kind of explode. And it was kind of fun to come across a bunch of these and just run your hands through them when I was a kid. Because they literally, like, any amount, just kind of explode the seeds. It's, if I remember, if they were mustard seeds or not, for it, because it's a wild plant for this. Oh yeah, they were one of the. I like them more than dandelions. There was another thing that I was thinking of that went along with this. But it's escaping me now. Oh, one of the now I remember. One of the new services that is kind of done in farming areas is there's people that basically their business is providing they have these hives that they set up. They have the bees and everything, and they set them up for the season. The farmers pay for them to set up these hives, and they basically rotate around to different. It's a business practice. Nothing like American invention to fill up a problem that's being occurring. And so they take the hives out there for a season and then move the hives to a different location at a different season as it's needed. Nothing like ADHD at all. Pretty much. Nope. Yeah, it's a beekeeping business kind of thing. But the thing is, commercial beekeeper, all of their stuff. So one of the reasons why, if I want to, I could probably do beehive things, but I'm allergic to bees. I am. We figured that out the hard way. So I couldn't do beekeeping as much as I'd find that fun in the sense of, you know, being able to take care of bees. I'm allergic to them. Not the bees! I know, right? Scientists are still working out how strong and widespread these effects of pollution are and how they operate. They're learning that pollution may have a surprising diversity of effects, from changing the scents that draw insects to flowers, to warping the creature's ability to smell, learn, and remember. This research is still young, says Jeff Riffle, a neuroscientist at the University of Washington. We're only touching the tip of the iceberg, if you will, in terms of how these effects are influencing these pollinators. Insects often rely on smell to get around. As they buzz about in their neighborhoods, they learn to associate flowers that are good sources of nectar and pollen with their scents. Although some species, like honeybees, also use direction from their hive mates and visual landmarks like trees to navigate, even they critically depend on the sense of smell for sniffing out favorite flowers from afar. Nocturnal pollinators such as moths are particularly talented smellers. They can smell these patches of flowers from a kilometer away, says Riffle. One of the effects of pollution, and what Gerling suspects was largely responsible for the pollination decline at the England site, is how it perturbs these flowery aromas. Each fragrance is a unique blend of dozens of components that chemically react and degrade in the air. Gases such as ozone or nitrogen oxide will quickly react with those molecules and cause the odors to vanish even faster than usual. For very reactive scents, the plume can only travel a third of the distance than it should actually travel when there is no pollution, says astrophysic scientist Jose De Florenz of the Penn State University in the U.S., who has simulated the influence of ozone on floral scent compounds. And if some of the compounds degrade faster than others, the bouquet of scents that insects associate with particular plants transforms, potentially rendering them unrecognizable. Gerling and his scientists observed this in experiments in a wind tunnel in which they delivered ozone. The tunnel was also outfitted with a device that steadily released a synthetic blend of floral odors. An actual flower would have wilted, says co-author Ben Langford, an atmospheric chemist at the UK Central Centre for Ecology and Hydrology. Using chemical detectors, the team watched the flowery scent plumes shorten and narrow as ozone ate away at the edges, with some compounds dropping off entirely as others persisted. The scientists had trained honeybees to detect the original flowery scent by exposing them to the odor, then giving them sugar water until they automatically stuck out their tongue-like proboscises to taste it upon smelling the scent. But when the bees were tested with ozonated odor, representing the edges of the scent plume, either 6 meters or 19.8 feet, or 12 meters, 39.6 feet away from the source, only 32% and 10% respectively stuck out their proboscises. The bee is sniffing a completely different odor at that point, Langford says. Researchers have also observed that striped cucumber beetles and buff-tailed bumblebees struggle to recognize their host plants above a certain level of ozone. Some of the most dramatic observations are at night, when extremely reactive pollutants called nitrate radicals accumulate. Raphael and his colleagues recently found that about 50% fewer tobacco hookworm moths were attracted to the pale evening primrose when the plant's aroma was altered by these pollutants, and white-lined sphinx moths didn't recognize the scent at all. This reduced the number of seeds and fruits by 28%. The team found in outdoor pollination experiments it's really having a big effect on the plant's ability to produce seeds. Can insects learn to recognize these transformed scents? For the insects to discern the new scents is rewarding. They need to smell them while they're feeding on sweet nectar. But the problem is, a flower's scent transforms only at some distance from the flower, Gerling says. Perhaps some insects can learn to follow polluted scents as they approach the flower, but this has been shown only for the tobacco hawk moth. Hawk moth, ugh. The pollutant can also make it harder for insects to learn. In a 2019 study, Gerling and colleagues first trained honeybees to recognize an odor using the sugar water proboscis method. They then exposed the bees to diesel exhaust. Later on, they tested the bees to see how many of them had retained their training and still reacted to the odor blend by sticking out their proboscis. Remarkably, 44% fewer honeybees were able to recall the scent 24 hours. Not 24. 72 hours after diesel exposure compared to unexposed bees. It looks like they are potentially not able to form these memories as well and hold on to those memories as well. Gerling says, the reason is unclear. Perhaps the gas somehow causes psychological stress in the bees' brains that leads to neurological impediments. This could hypothetically mean that in polluted air, bees may forget the original scents of flowers, or forget the polluted aroma if they do manage to learn those. Dirty air could even affect the insect's sense of smell. A few years ago, chemical ecologist Magali Profet of the French Center for Functional and Evolutionary Ecology, I slaughtered the name, I am sorry, and her team hooked up electrodes. Why am I having problems with that word today? Electrodes to the antenna of buff-tailed honeybees and fig wasps. They found that exposing the insects to ozone often made the odor-sensing organs much less responsive to smells. Bees and wasps exposed to moderate levels of ozone moved around aimlessly rather than towards the odors of their host plants. At high ozone levels, fig wasps even avoided the odor. Something is happening in the olfactory systems. Air pollutants have also have an influence when the plant absorbs them, says ecologist Laura Duck at the University of Würzburg in Germany. They can change plant metabolism and thus alter the blend of odor compounds that the flowers emit. Depending on the species, ozone can increase or decrease flower numbers, and possibly the quality and quantity of nectar or pollen. Ozone can also influence the timing of flowering, Luke said. It's possible that there's no plant reproduction at all if there is a complete mismatch between flowering and insect activity. Oh, yeah. And also, yeah, there is a level of, as you get older, you know, you can't smell as well. My mom, who's a lot older, doesn't have a sense of smell hardly at all. But also, illnesses can cause a certain amount of losing the ability to smell things, but also, yeah, ozone does affect that if I remember correctly. Or like, all that kind of stuff. Though, at this point, I should also say, don't quote me on that, because I don't have the article right up here right now, but from what I remember reading. It's hard to assess the magnitude of the effects on plant pollination, says urban insect ecologist Elsa Youngstead of North Carolina State University. Oh yeah, too many variables. Who co-authored the 2023 paper on pollution in cities in the Annual Review of Ecology, Evolution, and Systematics. Only a few studies, including Gerling's study in the UK and Riffle's moths, have quantified the effects. In general, one would expect impacts to be greatest in cities, which have borne the brunt of pollution since industrial times. Although this might also have led to adaptations, Youngstead says. Studies in non-urban plants and insects might be given a different picture than if we studied the plants and insect populations that have already been exposed to urban pollutants for hundreds of years. It's also unclear is the impact of pollution on insects. When insects fail to detect flowers, they miss a chance to get nectar or pollen for themselves, their young or their hives. They must travel further in search of flowery scents, sapping their energy, Fluent says. And the transformation of flower scents may be just one factor among many. Pollution particles can interfere with the ability of houseflies to smell food, for example, and ozone changes the pheromones of male flies so that they smell more like females, causing males to chase other males. Pollution can also more generally affect insect reproduction and survival. Putting all these impacts together, a recent study estimates that air pollution causes more than a 30% reduction in pollinator performances. Scientists need more research on different species, on their sensitivity to pollution, and their interaction with plants, especially in the understudied regions such as the global south. One of the other things is, it's occurring to me, is with dragonflies. Because the atmosphere and all this other stuff is getting hotter, male dragonflies wings are becoming more see-through and less black in color. And the females aren't recognizing the males to reproduce with them. If I remember correctly, that's what's happening because, of course, black traps heat. Dark colors trap heat. And so to keep themselves cool, their wings are slowly becoming lighter in color. And it become a problem with the way females recognize males is they have a darker wing set. So, from agricultural chemicals to climate change, we've all got all these other factors that are chipping away and reducing the fitness, making it harder for these insects to go through their normal life cycles and normal processes, Gerling says. If you then make just a little bit harder to find a flower, is that a tipping point that pushes that particular insect or hive over the edge? Right.